Hello, everybody. It's Mr. Billemeyer. We're going to move on to a new lesson today, 10.6, Writing Scientific Notation. So if you remember in lesson 10.5, we were given numbers in scientific notation, so we learned how to identify them. Remember that there are two factors in a scientific notation. The first factor is a number that's between 1 and 10, and the second factor is a base 10 raised to some exponent. So we learned how to identify them, and then we learned how to turn them into standard form, which, if we remember, is just numbers the way that we're used to seeing them, just regular numbers. Today's lesson is going to be doing the opposite. We're going to be given numbers that are in standard form, and we're going to go ahead and write them in scientific notation. So you'll see here on the page that there's one main key idea that they're asking us to look at, and it's about how we're going to actually write these numbers in scientific notation. There are two steps that we need to be aware of. The first step, we're going to move the decimal point so that it's located to the right of the leading non-zero digit. Just going to explain what that means real quick by writing down a number like 975. Okay? The leading non-zero digit means if we were coming from left to right, what is the first number that we would get to that's not a zero? So the 9 is the first number we would get to. That's not a zero. So they're telling us that we're going to move the decimal point to the right of that number 9. Okay, so we would put a decimal point there, and then we'll show you what we're going to do the rest of the way with examples. Step number 2 is we're going to count the number of places that you move the decimal point, and this will indicate the exponent of the base 10 that we're going to use as our second factor. And down below here, we can see that there are a couple of additional notes that tell us more about moving this decimal. So if we start out with a number that's greater than or equal to 10, so we're going to call that a large number, right? I'm going to write that down here. Anything that's greater than or equal to 10, we're going to call large, right? And we're going to use a positive exponent when we start out with a number that's greater than or equal to 10, okay? On the other side here, we have numbers between 0 and 1. We're going to call those our small numbers, okay? So if the number's between 0 and 1, it's a small number, and we're going to be using a negative exponent when we have numbers that are between 0 and 1, or what we're going to call our small numbers. All right, and you'll see this during the examples. Don't worry about this numbers between 1 and 10. I'm going to cover that in just a moment. So let's start off with example number 1, writing large numbers in scientific notation. Remember, any number that's greater than or equal to 10, we're going to consider a large number. So in the example, Google purchased YouTube for $1.65 billion. Write this number in scientific notation. So in order to do this, the first thing we're going to do is we're going to rewrite this large number without the commas. So 165, and there are 7 zeros. All right, so that's our number. Now you'll notice that there's not a decimal point to move, so we need to put a decimal point in there. And the decimal point in for any number that doesn't actually show one is always going to be all the way to the right after the last digit. All right, so it's not usually written, but that's where it would be. And now what we're going to do is we're going to move this decimal point and locate it so that there is only one number to the left of the decimal point, and that number cannot be a 0. So I'm going to move the decimal point 1 place, 2 places, 3 places, 4 places, 5 places, 6 places, 7 places, 8 places, 9 places. I'm stopping here because you'll notice that the number 1 is to the left of the decimal. So there's only one number to the left of the decimal, and that number cannot be a 0. If it was a 0, we would have to redo it and move it somewhere else. All right. So I'm going to put a box around. We're going to rewrite this number with the decimal point, but we're only going to rewrite this part. We don't need to write any of the zeros because they will have no effect on the value of our number when we're all done. So I'm going to write down 1.65. Okay. Now in scientific notation, we have to multiply this number by some base factor 10, and that 10 has to have an exponent. That exponent is going to be determined again by how many place values did we move our decimal point. So I'm going to recount those. 1, 2, 3, 4, 5, 6, 7, 8, 9. We moved it 9 places. So our exponent is going to be a 9. All right. And not 1 unit for each place that we moved. So we moved 9 places. We have an exponent of 9. That exponent is going to stay positive. Okay. And the reason that it is positive is because the number we started with was a number that was greater than 10, a large number. So any number that's a large number is represented with a positive exponent for our base factor of 10. Okay. All right. We're going to move to the next page. All right. So here's the special case, though. Numbers that are between 1 and 10, okay, they're not really considered large numbers and they're not really considered small numbers. Okay, so we have to know what to do with that. So for example, let's say we had the number 8. Okay, that's between 1 and 10. And we have to rewrite this in scientific notation. So the first thing we would do is we would add the decimal point to the right of the 8, because that's where it would be since we don't see it. And we were told that we needed to move the decimal point so that there was only one number to the left of the decimal point that's not a 0. Well, that's already where the decimal point is. So we don't need to move the decimal point for any numbers that are between 1 and 10. All right. And we're not including 10. I'm sorry. It's 1 up to everything except 10. All right. So what we would do is we would just rewrite the 8 as 8. We still have to multiply it by a base factor of 10. It's just we got to figure out what the exponent is. Well, since we didn't move the decimal any place values, our exponent would be 0. And if you remember in a previous video, anything raised to the 0 power is equal to 1. So I could rewrite this as 8 times 1, which just equals 8, which is what I started with. Okay, so for any number that's between 1 and 10, not including 10, we're just going to multiply that number by 10 to the 0 power to make it in scientific notation. All right, because we're not going to move the decimal anywhere. We're moving it 0 spaces. Hopefully that makes sense. All right, so we're going to go ahead and move to the next page. And you will see that there are some on your own problems here for you to work on. So go ahead and pause the video, work on these problems, and then restart the video when you are ready to check your answers. Okay, hopefully you have completed those problems. So let's go ahead and start with number 1. We are going to rewrite the number without any commas. And we're going to locate our decimal point all the way to the right. Step number 1 is we need to move that decimal point so that there's only one number to the left of it that's not a 0. So I'm going to move 1, 2, 3, 4, and I'm going to stop there because the 5 will be to the left of the 0. Now, when we rewrite this number, I could rewrite it as 5 with a decimal point, but we don't need any of these zeros because they are not going to add any value to our number. So we don't write them, which then means we don't really need that decimal point right here because we don't typically write numbers like 5 with a decimal point next to it. So that's step number 1. Step number 2 is to multiply this by our base factor of 10, right? And we count the number of decimal places to get our exponent. So we moved it 1, 2, 3, 4. So our exponent is going to be a 4. And it's going to stay positive because we started with a large number greater than 10. In number 2, rewrite the number without the commas. Locate our decimal all the way to the right. And then move our decimal point 1, 2, 3, 4, 5, 6, 7 places to the left. There's only one number to the left of the decimal point, so that's the right spot. We're going to only write the part of the number that we need. We don't need the zeros. So 2.5. times our base factor of 10. And again, we moved 1, 2, 3, 4, 5, 6, 7 places. So we're going to have 7 for our exponent. And remember, we started with a number that is bigger than 10. So our exponent needs to be a 7. That's positive. Okay. So it's a positive exponent once again. In number 3, we start with 683. There are no zeros in this problem, so we don't need to worry about them. Our decimal point would be to the right, and we're going to move it 2 places to the left because there's only one number to the left of the decimal point now. That's not 0, the 6. And then we're going to rewrite that number as 6.83. We're going to multiply by our base factor of 10, and we moved the decimal point 2 places. So that gives us an exponent of 2. And again, our exponent is positive because we started with a number larger than 10. So a large number. All right, hopefully you got those right. If not, make sure that you use the office hours to connect with me so that I can give you further explanation. All right. And now we're going to write numbers in that are really small, all right, in scientific notation. So let's take a look at example 2. The 2004 Indonesian earthquake slowed the rotation of the Earth, making the length of a day 0.0000268 seconds shorter. Write this number in scientific notation. So again, I'm going to start by writing down the number 0.0000268. Now you'll see that we don't need to add a decimal point to this number because it already contains one. But we still have to do the same process. We're going to take this decimal point and we're going to move it so that it's to the right of the first number that's not a 0. So I'm going to move it 1, 2, 3, 4, 5, 6 places to the right. You'll notice that I just passed a number that's not a 0. So there's only one number that's to the left of the decimal point that's not 0. And this is the part of the number that I'm going to rewrite. I don't need these zeros. They don't add value. And so I'm going to rewrite it as 2.68. We're going to multiply by a base factor of 10, right? Or a base 10 factor. And now I'm going to count how many place values I've moved my decimal point again. 1, 2, 3, 4, 5, 6. So I moved 6 places. So I'm going to put a 6 as my exponent. But the number that I started with was really, really small. It was between 0 and 1. That means this exponent needs to be negative, okay? Because negative exponents tell us that we started with a really small number, okay? That's between 0 and 1. Simple as that. Okay, let's move to the next page. Here we go. All right, there's a few more on your own problems here, writing some small numbers in scientific notation. So go ahead, pause the video, take care of those, and then restart the video when you're ready to check your answers. All right, number 4, we're going to start by rewriting our number. Okay, that's supposed to be a decimal point. All right, so we have a decimal point already. So we're going to take that decimal point and we're going to move it to the right so that it's past the first number that's not a 0. 1, 2, 3. We just passed the 5. That's where our decimal point is going to be. So this would be the number that we're going to write down. Now, since there's nothing past the decimal point, we don't really need the decimal point, so we're not going to leave it there. And then we have to multiply by our base 10 factor. And since we've moved the decimal point 1, 2, 3 places, our exponent is a 3. And it's a negative because we started with a number that was between 0 and 1. Okay, a small number. Number 5, we're going to do the same thing. Start by writing down, let's see, there are 1, 2, 3, 4, 5, 6 zeros. So 1, 2, 3, 4, 5, 6. and 2 3s. Sorry, that's a 3 over there. All right, I'm going to move my decimal point. 1, 2, 3, 4, 5, 6, 7. Stopping here because I just passed the first number that's not 0. And this is the only part of the number that I'm going to rewrite. So I'm going to rewrite 3.3, okay, times our base 10 factor. And I move the decimal 1, 2, 3, 4, 5, 6, 7 places to the right. So my exponent is a 7. And since I started out with a really small number, it should be a negative exponent. So it's negative 7. All right. In number 6, I'm going to rewrite the number. So my number is 0.000506. Okay. I'm going to move my decimal point past the first number that's not a 0. 1, 2, 3, 4. Stop here because we just passed a 5. So that's where it's going to end up. I'm going to write all of these numbers. 5.06. Now you'll notice that there is a 0 in this number, but that 0 is between two other numbers, so I have to include it. I can't get rid of that number. It's only if it's on an end of a number that we don't really need it. And we're going to multiply by base factor 10. And we moved our decimal point 1, 2, 3, 4 places to the right. So that's a 4. And since this number was a really small number that we started with, we need a negative exponent. Okay. One last thing that I wanted to show you is that this first factor, and that first factor, the rule is that the first factor always needs to be a number that's between 1 and 10. So you can see that where I moved my decimal point is always giving me a number that's between 1 and 10. So I just wanted to point that out to you. All right. All right. So using scientific notation, so kind of a real world situation where somebody might use this. So we have an album receives an award when it sells 10 million copies. There's an album that has sold 8,780,000 copies. How many more copies does it need to sell to receive the award? So when we're trying to find out how many more, right, that means we need to subtract. We're going to take the larger amount and subtract the smaller amount to figure out how many more we still need to be able to sell. So we're going to start with the 10 million. That's a comma. And we're going to take away the 8,780,000. All right. And when we go ahead and do that, we're going to end up with 1,220,000. All right. If you go ahead and subtract those, that's what you'll find. But they want us to rewrite this number in scientific notation. So I'm going to start by writing the number with no commas. All right. I don't have a decimal, so I'm going to locate one all the way to the right. And then I'm going to go ahead and move that decimal to the proper location for scientific notation. So I'm going to move it 1, 2, 3, 4, 5, 6 places to the left. So it's now going to be there. Remember, I only need to write this part of the number, not the zeros. So I have 1.22 times 10. And since we moved it 6 places to the left, our exponent is going to be a 6. But remember, we're starting out with a number that's really big. All right. So that means our exponent is going to stay positive. I know we just did some problems where we had negative exponents, but remember, they're only for really small numbers. All right. This was a really large number, so it has to be a positive exponent.